Right, let's look at the analytic functions. Right, here's the definition. F is called analytic at x equals a if its Taylor series at x equals a converges to the function f of x for all x in some open interval containing a. Right, so let's look at this example. Let's say f of x is 1 over 1 minus x, right? So we know that this has a Maclaurin series, which is centered at x equals 0. So summation n goes from 0 to infinity and x to the n, right? And we know that this guy converges if x is between -1 and +1. So if x is in open interval from -1 to +1, right? So since this Maclaurin series converges some open interval containing 0, so we know that f is definitely analytic at x equals 0, right? But how about x equals 1, right? Then the problem is you can see that the f is f of 1. If you plug in 1 here, the denominator becomes 0. So this guy, f of 1, is undefined. And so are all the derivatives. So, f prime of 1 is also undefined. And so on. Alright, so which means that we cannot find the Taylor series centered at the 1. So therefore, Taylor series would not converge. So therefore, f is not analytic at x equals 1 or x equals -1. Maybe same thing at x equals -1 for the same reason. All right, that's it. I hope that this was clear.